Let's solve problems. Okay, let's say we have the matrix A is equal to 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3. And what we have to do is find the eigen value and eigen vector. Now we know the equation Ax is equal to lambda x, and this becomes A minus lambda I x equal to 0. And we know that we need to figure out the determinant to figure out the characteristic equation. So A minus lambda I equal to 0. Okay, let's do that. So this would be 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda equal to 0. This would be 8 minus lambda, 7 minus lambda times 3 minus lambda minus 4 minus 4. Now minus into minus plus 6 times minus 6, 3 minus lambda minus 2 times minus 4, then plus 2 times minus 6 minus 4 minus 2 times 7 minus lambda equal to 0. 8 minus lambda, 21 minus 10 lambda plus lambda square minus 60 plus 6 times minus 18 plus 6 lambda plus 8 plus 2 times 24 minus 14 plus 2 lambda equal to 0. 8 minus lambda, lambda square minus 10 lambda plus 5 plus minus minus 18 plus 8 is minus 10. So this becomes minus 60 and plus 36 lambda plus 48. 24 minus 14 is 10. 10 times 2 is 20 plus 4 lambda equal to 0. Let's multiply this off. 8 lambda square minus 80 lambda plus 5h 40 minus lambda cube plus 10 lambda square minus 5 lambda minus 60 plus 36 lambda plus 20 plus 4 lambda equal to 0. Now let's see how to simplify this. Minus 80 minus, no, well, let's take 40. 40 minus 60 is minus 20, minus 20 plus 20 is 0. So 40, 60, 20 goes on. Now what are we left with? Let's look at lambda squares. Okay, so that is 18 lambda square. Now let's look at lambda. So this comes to how much? 36 plus 4 is 40. 40 minus 5 is 35. Minus 80 plus 35 is minus 45 lambda minus lambda cube equal to 0. Okay, let's take out minus. So minus lambda cube, why not take, let's take minus lambda out. So we left with lambda square minus 18 lambda plus 45 equal to 0. So which means one of the solutions is lambda equal to 0. Okay, So now we need to factorize this factor. Okay, so this would be lambda, and let's put this minus, we can take it out to the other side, it gets cancelled out. Okay, so here we will have 15 3 is 45, so 15 3. Now what will be the signs? This should be minus, both should be plus, so minus minus, so that means lambda equal to 0 or lambda equal to 15 or lambda equal to 3. Therefore lambda equal to 0, 3, 15. So these are the eigen roots or values. Now corresponding to these we have to figure out the eigen vectors. Let's figure out for lambda. Let's say this is lambda 1, lambda 2, lambda 3. So lambda 1 equal to 0. In that case, our vector, our matrix doesn't really change, right? So this becomes 8 minus 0, 8, minus 6, 2, minus 6, 7 minus 0 is 7, minus 4, 2, minus 4, 3. Now let's reduce it. R3, 4, R3 minus R1. We get 8 minus 6, 2, minus 6, 7, minus 4. This becomes 0, minus 10, and 10. Next, R2, 8 R2 plus 6 R1. So the matrix becomes 8 minus 6, 2, 0, 20, minus 20, 0, minus 10, 10. Now we can take care of the third row. R3 to R3 plus R2. So the equivalent matrix would be 8 minus 6, 2, 20, minus 20, 0, 0, 0. And what we can do is now R2, we can divide it by 20. So we get 8 minus 6, 2, 0, 1, minus 1, 0, 0, 0. Okay. So now what do we do? Let's convert this back to the equation forms. 8x minus 6y plus 2z is equal to 0. Y minus z is equal to 0. And this can be written as y is equal to z. Okay, let's do the substitutions. 8x minus 6y plus 2y equal to 0. 8x minus 4y equal to 0. 8x equal to 4y, or we can say 4. Let's take this to this side. So 4 by 8y, 4 ones, 4 twos, which is half of y, which means we can write it as y is equal to 2x. Now, here if you notice, we have z in the equations, and in this we have y and z, but x is equal to we don't have. So let x is equal to k, then y becomes 2k and z becomes equal to 2k, because z is equal to y. So that means our eigenvector corresponding to lambda equal to 0. So our eigenvector corresponding to lambda 1 equal to 0 is x equal to k, 2k, 2k. If k is equal to 1, then this would be 1, 2, 2k. Now let's take the second one. Lambda 2 is equal to 3. So our matrix will become 8 minus 3, 5, minus 6, 2, minus 6, 7 minus 3 is 4, minus 4, 2 minus 4, 3 minus 3, 0. Okay, again, now we start reducing it. So R2, 5 R2 plus 6 R1. So the equivalent matrix would be 5 minus 6, 2. This would be 0 minus 16 minus 8, 2 minus 4, 0. Okay, now let's take care of the third row. R3, 5 R3 minus 2 R1. Equivalent matrix would be 5 minus 6, 2, 0 minus 16 minus 8, and this would become 0 minus 8 minus 4. Okay, R3 replaced with 2 R3 minus R2. This will become 5 minus 6, 2, 0 minus 16 minus 8, 0, 0, 0. R2 divided by minus 8. 5 minus 6, 2, 0, 2, 1. 0, 0, 0. Now let's convert this into equation form. So we get 5x minus 6y plus 2z is equal to 0. 2y plus z is equal to 0. That means we can write z is equal to minus 2y. Now let's do the substitution. F of fx, 5x minus 6y plus 2z. Z is minus 2. Y equal to 0. 5x minus 6y minus 4y equal to 0. 5x minus 10y equal to 0. 5x equal to 10y, or x is equal to 2y. Now let y is equal to k. Then x becomes 2k and z becomes minus 2k. So our eigenvector corresponding to lambda 2 equal to 3 is x equal to 2k, k minus 2k. And if k equal to 1, then x becomes 2, 1 minus 2. We are still not finished because we have a third eigenvalue. So lambda 3 equal to 15. So now the matrix becomes 8 minus 15 minus 7 minus 6, 2 minus 6, 7 minus 15 minus 8 minus 4, 2 minus 4, 3 minus 15 is minus 12. Let's reduce it. So this take care of, let's take R3, 3 R3 plus R2. So this becomes minus 7 minus 6, 2 minus 6 minus 8 minus 4, 0 minus 20 minus 40. Now let's take care of R2. 7 R2 minus 6 R1. The matrix becomes minus 7 minus 6, 2 minus 6 minus 8. No, then this we have to apply that rule. This becomes 0 minus 20 minus 40. 0 minus 20 minus 40. Now R3 minus R2, and R2 we can divide it by minus 20. So the equivalent matrix would be minus 7, minus 6, 2. First we take care of the third row. So this becomes 0, 0, 0. And then we take care of the second row. So this becomes 0, 1, 2. And now we convert it into equation form. Minus 7x minus 6y plus 2z is equal to 0. Y plus 2z is equal to 0. So which means y is equal to minus 2z. Now let's do the substitution. Minus 7x minus 6 times minus 2z plus 2z equal to 0. Minus 7x plus 12z plus 2z equal to 0. Minus 7x plus 14z equal to 0. Minus 7x equal to minus 14z. So which means x is equal to 2z. Now, which is the independent one here? Z. So let z be equal to k. Then y becomes equal to minus 2k. And x becomes equal to 2k. So eigenvector corresponding to lambda 3 equal to 15 is k, no, not k, 2k, minus 2k and k. And if k is equal to 1, then x is equal to 2 minus 2, 1. So that is finding eigenvalues and eigenvectors. Okay, let's do one problem with just with a 2 by 2 matrix. Remember, these matrices have to be square matrices. So let's say A is equal to minus 2, minus 1, 5, 4. We have to figure out the determinant. Minus 2 minus lambda minus 1, 5, 4 minus lambda equal to 0. Minus 2 minus lambda, 4 minus lambda, minus 5 times minus 1 equal to 0, which means this will become minus 8 plus 2 lambda minus 4 lambda plus lambda square plus 5 equal to 0. Lambda square minus 2 lambda minus 3 equal to 0. And we need to factorize this. Lambda, lambda. No, 3 ones 3. So 3 minus 1 is 2. So 3 and 1. Now we have to figure out the signs. So here this has to be minus. So one of them has to be plus. But this is minus. So bigger one will be minus plus. Okay. So which means lambda is equal to 3 or lambda equal to minus 1. So eigenvalues of A with respect to x are minus 1 and 3. So let's take lambda 1 is equal to minus 1. So corresponding to this eigenvalue, we have to find the eigenvector. So let's figure out the vector. So minus 2 minus lambda. So minus minus 1 plus 1 minus 1, 5, 4 minus lambda. So minus minus 1 plus 1. So here this becomes equal to minus 1, minus 1, 5, 5. So here we can say R2 minus or plus 5R1. So which means the equivalent would be minus 1, minus 1. And this will become 0, 0. And then we can say R1 divided by minus 1 or multiplied by minus 1. Doesn't matter. Either way, we get 1, 1, 0, 0. So therefore, x plus y equal to 0, which means x equal to minus y. That means we can take any one of them. So let's say x is equal to, or since we are using x equal to minus y, we can say y equal to k. That means x is equal to minus k. So therefore, the eigenvector corresponding to lambda equal to minus 1 is equal to minus k. If k equal to 1, x1 would be equal to minus 1, 1. Okay. Now, similarly, lambda 2 equal to 3. Now what do we do? Again, minus 2, minus 3, minus 1, 5, 4 minus 3, which gives us minus 5, minus 1, 5, 1. So here we can say R2 plus R1, R2 plus R1. Yes. So the equivalent matrix would be minus 5, minus 1. This will become 5 plus minus 5, 0, 0. And we can say R1 divided by minus 1. So the equivalent would be 5, 1, 0. So the corresponding equation form would be 5x plus y equal to 0. Y is equal to minus 5x. Okay, so x is the independent. So let x equal to k. Then y becomes minus 5k. So therefore, vectors corresponding to lambda 2 equal to 3 is x equal to k minus 5k. If k is equal to 1, then x is equal to 1 minus 5. It is pretty straightforward to verify whether this is correct or not. Just substitute in the equation x equal to lambda x. Okay, so let's do that. Minus 2 minus 1, 5, 4, and x is 1 minus 5 is equal to lambda. Lambda is 3, 1 minus 5. So let's do this. Minus 2, 1 is minus 2 plus 5. Then 5 minus 20 is equal to 3 minus 15, which is 3 minus 50. Like that, you can do it for any of the other solutions. That's it for now. Bye.